In this section, we're going to focus on graphing different types of functions. We're going to start by making a table. This one is just a basic linear function, and we always want to consider any restrictions that are on the domain, but since this is a linear function, anything is fine. So we'll pick a couple of negative values, -2, -1, we'll choose 0, 1, and 2. And then I'm just going to take each value and substitute in. So 3 times -2 minus 1, that's -6 minus 1 is -7. And I'm going to continue to do the same thing here. 3 times -1 minus 1 is -3 minus 1, or -4. And then when I substitute 0 in, 3 times 0 minus 1 is -1. 3 times 1 minus 1 is 2. And then 3 times 2 minus 1 is 5. So there are my points. Now, there's my coordinate plane, and so let me graph my points. I'm going to start with the point -2, -7. So -2, 1, 2, 3, 4, 5, 6, 7. So this is the x-axis and y-axis. And then -1, -4. So -1, 1, 2, 3, 4. 0, -1. And then the point 1, 2. And the point 2, 1, 2, 3, 4, 5. And then I would use my ruler and connect the dots. Then I get my line. This one is not a line, and there is actually a restriction on the domain. We want to make sure with this one that x does not equal 3. So I'm going to make my table, and I need to stay away from +3 because I don't want to have 0 in the denominator. So I can choose some positive, some negative again. Let's choose -3, -2, -1, 0, 1, 2. We'll skip over 3. We'll try 4 and 5. And let's see what happens. This ends up being 1 over -6, so -1/6. 1 over -5, so -1/5. And then 1 over -4. 1 over -3. So these are all little itty bitty numbers. And then if I substitute 1 in, I'm kind of getting offline here. Let's make sure we do that. Okay. And so then 1 over -2, so that's -1/2. 1 over -1, so that's -1. And then 4 would be 1 over 1, that's +1. And 5 would be 1 over 2. Alright, so let's graph these. See what happens here. So I can try to graph the point -3, -1/6, -2, -1/5, -1, -1/4, 0, -1/3, 1, -1/2, 2, -1, 3 is what we call an asymptote, when x is equal to 3. And so what you can see maybe is happening here is this is getting closer and closer to the x-axis, and then if we continue to, let's say that I did like 2.5, I'd get closer and closer to 3, but I'd never actually get to 3. And then we have the point 4, 1, and then 5, 1/2, and if we actually kept going, the same sort of thing would happen here. It's kind of a neat little graph of a rational function. Next, this one is okay for all of our x values as well, so I don't have to stay away from anything. So again, I can pick a few negative, -2, -1, 0, 1, 2, 3, 4, and we'll see what happens. If I put in, this is an absolute value function, so if I put in -2, I end up with the absolute value of +2, which is 2. If I put in -1, I end up with the absolute value of 3, which is 3. Here I'd end up with 4, 5, 6, 7, 8. Let's try a couple more negative. Let's try -3 or -5 and see what happens. So -3, I'd end up with +1. -5, I'd end up with +1 again. Alright, so let's plot some of our points here. I'm going to plot the point -2, 2, -1, 3, 0, 4, 1, 5, 2, 6, 3, 7, 4, 8. And so far I've got that part going. This doesn't give me a whole picture though. So -3, 1. -4 would actually be 0 here, and then -5 is also +1. So this graph is actually going to go like that. This one is also good. We can pick any x and y, or any x that we want. There's no restrictions on the domain here. So let's pick from -3, -2, -1, 0, 1, 2, 3. And let's see what happens. If I put -3 plus 1 in, and square that, I end up with 4. And then -2 plus 1 squared, I'll end up with 1. Here I'll have 0, 1, 4, 9, and 16. So plot my points. -3, 1, 2, 3, 4. -2, 1. -1, 0. 0, 1. 1, 4. 2, 9. This one is a quadratic. It's a parabola when you graph it. It's supposed to be a U shape. Now, here are two linear equations. This one we're going to use the slope and y-intercept. In order to do that, we need to solve for y. So to solve for y, I'm going to get it all by itself. Subtract 3x from both sides. And divide by -2. My slope is this number sitting in front of the x, and my y-intercept is that minus 8 that's on the end. So I start with my y-intercept. I'm going to count down to negative 8. 1, 2, 3, 4, 6, 7, 8. And then a slope of 3 over 2. I'm going to go up 1, 2, 3, and to the right 2, because positive slope goes up from left to right. I'm going to do that a couple of times. And then I would use my straight edge, my ruler, to connect the dots. And then the last one, we want to use the x and y intercepts. So I'll start by finding the x-intercept. I'm going to put 0 in for y and solve for x. So negative 4x plus 0 equals 20. Negative 4x equals 20. Divide by negative 4. So one of my ordered pairs is going to be negative 5, 0. That's the x-intercept. Then the y-intercept, I'm going to put 0 in for y, 0 in for x, and solve for y. And then divide by 5 on both sides. And so we have the ordered pair 0, 4. Okay? So let's plot our points. First of all, I have the point negative 5, 0, 1, 2, 3, 4, 5, negative 5, 0. And then the point 0, 4. 0, 1, 2, 3, 4. And there's my line.